Today topics floating point tricks. Introduction to floating point tricks. Floating point arithmetic is essential for the scientific and engineering computations. Tricks can improve performance, accuracy, and robustness in numerical algorithms. Understanding these techniques helps avoid common pitfall in a floating point calculations. Floating point representations basics. Floating point numbers are represented by a expansion and maintenance and sign. IEEE 754 is the most common standard from floating point representation. The format allows for a wide range of magnitude but introduced rounding errors. The importance of precision. Single and double precautions determines the number of significant digit stored. Higher precautions reduced rounding errors but demand more computational resource. Choosing the right precautions depends on the application's accuracy requirements. Trick 1. Avoiding subtraction cancellation. Subtractive cancellation occurs when subtracting nearly equal numbers, causing loss of precautions. Rearranging expressions to minimum calculations, such as factoring or using identities. For example, compute A into 2 by B into 2, such as A minus B of A plus B. To improve accuracy. Trick 2. Scaling to prevent overflow and underflow. Scaling variabilities to keep intermediate calculations within the responsibility range. Use normalization techniques or longitudinal transformation for a large or small numbers. Prepare scaling, maintaining numerical stabilities and prevents overflow or under, underflow errors. Track 3. Kahan summation algorithms. The Kahan summation reduce errors accumulation when summing many floating point numbers. It keeps a running computations for last underbite during additions. Implementing these algorithms improve the accuracy of summations in a numerical computations. Track 4. Using fused multiply adding FMA. FMA perform a multiply and add in a single operations with only one rounding the step. It improves both speed and accuracy in polymery, elevation, and matrix operations. Many modern process support FMA institutions, enable FNC computations. Track 5. Exploiting IEEE 754 special value using NAN, not a number, and infinity to handling exemption exceptional cases gracefully. Checking for these special values can prevent unfinite behavior. Prepare handling for special values improves robustness in numerical algorithms. Track 6. Rounding mode control. Adjusting the rounding mode, example, towards 0, nearest, downwards, upwards can influence accuracy. Some algorithms benefit from specifying rounding modes to minimize errors. Many programs environment allows explicit control over rounding behavior. Traction, error analysis and backward stability. Analyzing the error programming helps to designing more stable algorithms. Backward stable algorithm produce results as if a competitive extensively on the significantly probable output. Ensuring backward stability is key for a relevantly floating point computations. Right. Using algorithm computational logarithm convert multiplications into additions, reducing overflow risk. There are useful to algorithms innovating very large or very small numbers. Logarith- Logarithmic transformations can be improve both numerical stabili- stability and efficiency. Track avoiding zero division and checking for a denormals. Zero division and denormals numbers can causing undefined behavior or slow down. Implement checks and handle these cases explicitly in algorithms. Prepare handling issues consistent and predictable numerical results. Track proper testing and validation. Test algorithms can with edge cases such as very large, small, or near zero values using no algorithm solutions to verify accuracy. Regular validations helps catch errors stemming from the floating point issues. Practical tips for development. Always document suggestions about predictions and surrounding behavior using libraries and hardware features optimized for a numerical stability. Continuously profile and testing floating point operations during development. Summer and floating point tricks. Effective tricks include scaling, submission algorithm, and special value handling. Awareness of a preservation and surrounding errors is a crucial. Application these are technicals helps to improve the reliability and performance of a numerical computations. Thank you.